Alright, stream is live. Hello. Let's see, how do you keep noise down in your apartment? Probably build an enclosure, and you're probably going to have to sacrifice your depth of cut. Alright, so let's officially kick things off. Hello guys, welcome to the Carbide Office Hours episode. Is this episode? Episode 4? Let's go with episode. How's everyone doing today? It's a little overcast here in California, Southern California, but still doing well. Hello, Leanne. I will acknowledge you today. For those that don't know, Leanne is one of our customer support specialists. She often hounds me with questions, but she's also becoming a proficient CNC user as well. For those of you who are just tuning in or who haven't looked at what we have on the agenda today, today our project of the day is going to be to recreate this pen case that I whipped up this week. It's something that you could model in a more advanced CAD software, but geometry like this is totally doable with just a CNC and some basic hand or power tools. Before I jump into this, though, I want to cover a couple small things. For those that don't know, recently we updated Carbide Create with a few new features and a couple fixes. Right now it's still in beta, but if you go to the beta download site, we currently have build 467 available. And so two things. One, there was an instance where you might get some gouging, where some of the roughing toolpaths would clip through areas that were supposed to be part of the model. That has since been fixed, and then now in version 467 of Carbide Create, we've added a little feature where if your stock is, let's say, half an inch tall, and then let me create a quick piece of geometry that is more than half an inch tall, select that rectangle, and sort of extrude it up, make it, let's say, 0.75 inches tall. Apply that, show that. Any geometry that extends above your stock will now be highlighted in red. So that should help you keep track of your model and what you're designing and how to keep it within the limits of your stock. Otherwise, when you go to generate a toolpath for something that sticks up above it, it might get ignored. Additionally, in the lower left corner, you'll see the cursor position. So now you can see when you hover over different parts of your geometry how tall something is and where your cursor is. And that'll just help you figure out where you can build up more material or where you need to remove material. So it's just something nice to keep you, just give you an awareness of what your model looks like and some of the statistics about it. But keep using Carbide Create Pro. Let us know what you think. We are always improving our software, so the more feedback you give us, the better we can make the software for you. Hello Sweden, hello Canada. Hope y'all are staying safe over there. Alright, so without further ado, let's start making a pen case. I'm just going to make a new canvas, discard everything. And so I'm making a couple assumptions here. I have everything in my fancy notebook. I like to sketch out everything on paper first. I find it's just easier to keep track of dimensions and to know where everything's arranged. If you are a visual drawer, you could design something in Illustrator or heck, even Fusion 360, but we're trying to keep the tools simple here today. So my pen case is going to be about 7.5 inches wide and under 2 inches deep. Well, 3/4 of an inch deep-ish, accommodating a pen of at least 6 inches and the width of the pen case. Well, let's just draw this. Width in X, 7.5. Height, let's make that in Y-axis, 2 inches. We might change this as we go. For the stock, I'm going to assume that we have the perfect thickness stock. Otherwise, you're going to have to machine some material off the top and then account for that later. This just makes our math a little simpler. So I'm going to say our stock thickness is 0.625 inches. Hardwood, Shapeoko, document background. I want my spacing in 1/4 inch grids patterns. Okay, So this is our canvas, and so the first feature, I guess, is the overall dimension of it. So if you look at this shape, it's starting from a rectangle, and then I put a 30-degree bevel on each of the corners. So I'm going to start by making a rectangle. I'm going to say I want this rectangle to be 1.75 inches high, and then about 7.5 inches wide. Let's apply that, see how it looks. I'm going to reposition this and center it. I like aligning everything with the grid for now, just because there are going to be some features that I snap to this grid. And so if everything's centered, even though you can see that the corners of this don't fall on a grid, that's totally okay. Let's see, to put those bevels in the corners, I'm going to make a triangle. Triangles having 60-degree angles. You take half of that, that gives you 30. So let's make a triangle. Number of sides of this polygon will be 3. Height, let's try 1 inch for now. Let's see what that looks like. Okay, not quite the right orientation, so I'm going to use the rotate tool, and I'm going to rotate that. Let's go -90. Is that the right direction? Well, it's the wrong way, but it works for the other side. So I will actually just reposition this by dragging the bottom node and then snapping that over to the far right side. Now this triangle isn't tall enough for how I want to design this, so I'm just going to increase the height a little bit more, apply that, and then re-snap that back to that grid point. Perfect. So we got one of those. Let's make another one. Copy, let's Control-C or Command-C, depending on Mac or PC, and I'm going to rotate this 180 degrees. And then snap that point to one of our grid points. And then now that gives us basically the bevels that we're going to cut off the edges. So let's do that with a Boolean operation. I'll select the main body. I will, I think, shift-click, select a triangle, and do a Boolean subtraction. And then we'll pick the other one, select the main body, shift-click, triangle, Boolean subtraction. Okay, so that gets us the shape that we're looking for. And then now to make a slot. You'll notice there is no slotting tool in the vector palette, so we're going to have to recreate that. I'm going to use a rectangle, do about here-ish. Let's say, yeah, about ½ an inch high, or that'll be the pen diameter that this thing will accommodate, and 5.5 inches long. That's going to be, that'll be the pen width. We can do a fillet to round over the corners. I'm just going to do a little more Boolean vector addition though, just for funsies. So I'm going to make a rectangle, but then I'm going to add 2 circles. So on the midpoint of that rectangle's sides, we'll make a circle there, unselect, make another circle over here. And then I will select my circle, rectangle, circle sandwich and do a Boolean union. So that'll form the slot where we can stash away our fancy pens. And let's see. Let's add a finger hole feature. So I'm going to do a circle. I'm going to make the radius, let's try 0.625. Is that too big, too small? Let's take a look. That looks about right. And then the concept I had for this pen case, since I don't have any good concealed hinges or small hinges that I can use to make like one of those pen cases that have a flip-up lid, is I decided to just add a sort of a dowel pin, but it has a flange on the top, so it'll capture the lid, and then use a magnet in the opposite corner to sort of snap things closed. So we need to add in those features. I will create a small circle, of radius 0.125 inches since I have a 1/4 inch diameter magnet, and I don't have a good snapping point except for the middle there. That's not exactly where I want to place it, but let's go with that for now. I'll show you guys the actual model that I use, and I'll probably post that to Cut Rocket so you guys can take a look at it. But for this exercise, the exact placement of these features doesn't really matter too much. So this will be our hole for the magnet. I'm going to copy that, and I'm going to relocate the other one to the opposite corner. That'll be the hole that we will glue our dowel in. And then, let's see. That's pretty much all there is for designing the overall shape of the pen case. We can do this two ways. We can do this in a purely 2D fashion, or we can do this using Carbide Create Pro. Depending on how much time we have, we might run through both, but I'm going to do this strictly 2D for now. So this will be the body of our pen case. So I'm going to save this. Let's go, I'll throw it on the desktop for now. Pen case body. Save that. I'm going to save a second version of that as well. Save as pen case lid. And since I did save as, this current file that I'm working with will be the lid. The lid doesn't need the cutout feature, so I'm just going to take that away. And it's going to have the magnet on the bottom of the lid. So you'll see here that from the top you only see one cutout. So that magnet is underneath, you can't see it. So we're not actually going to cut it in this location in the bottom right corner. We're going to do it, we're going to have to flip the piece over, and I'm going to use a point over here. Bottom left corner, sort of just virtually. That's going to be a placeholder for now. We can address that later. And while I'm messing with the lid file, we know the lid's going to be thinner. I'm going to assume my stock thickness is maybe 0.2 inches. That's close enough. Okay, so let's do the tool pathing for the lid first, since we have this open. I'm going to create several tool paths. The first one I want to do is actually I'm not done modeling. Sorry about that. The pin feature here is a 1/4 inch diameter through both pieces, but there's a flanged portion of that dowel pin on top that is 0.375 inches in diameter, and that just helps capture the lid. So I'm going to make another circle, radius 0.1875. American units are so nice. Just kidding. And then for tool pathing, we're going to sort of counterbore this hole. So I'm going to pick the larger circle, counter that, hit a contour, apply a pocketing toolpath with an 1/8 inch end mill, change tool, get rid of the 1/8 inch default one, replace that with a specialized hardwood 1/8 inch end mill. Okay, max depth, let's go 0.07 inches. We'll call this counterbore. Hit OK, and then let's machine out the inner circle. That'll be a 1/4 inch all the way down. Contour, pocket or contour, it doesn't matter here because an 1/8 inch end mill will just fill out the entire hole when it goes around. This one we want to go all the way to the bottom. Our start depth, since we pocketed away a lot of stuff before, we can actually start this 0.07 inches down. We'll call this the pivot hole. And so let's see, where does that leave us? We have 2 holes, but we need the profile of the lid cut out. So hide simulation, pick the outer contour, apply another contour toolpath, work on the outside of this one, start at the top, work all the way to the bottom, And then this will be our cutout toolpath. And let's see what this looks like. Looks like pretty much what we need. Now, one other permutation that I'm going to do here, I'm going to make another group to cut out this toolpath, so I can deal with that separately. So once I machine out the top of the lid, I'm going to flip it over, and I'm going to do a little shallow pocket for my 16th inch end mill, or 16th inch tall magnet. Magnet pocket, max depth 0.0, let's go 6.5. I'd rather cut this pocket just a tiny bit deeper than necessary, because if you put glue or anything underneath this magnet, it'll sort of elevate it, and I don't want the magnet to sit proud of this face. And then I think that should be all we need. So I'm going to disable this for now. And then these are going to be the toolpaths for the lid. I'll save that. I'll reopen the lid file, or the body file, sorry. Having a massive brain fart today. Alright, so toolpathing for this. We can do this in several different ways. I want to make it so that the recess for your fingers to grab the pen don't go all the way down to the same depth as the pen cavity. So I'm going to machine this as a separate pocket from the pen cutout, and otherwise I would just totally do a Boolean operation, combine them, and just apply a single pocketing toolpath. In order to create sort of a rounded type pocket for that, though, with the fillet at the bottom, since I'm not using Carbide Create Pro's toolpath for this, I'm just going to machine out and pocket this with a ball end mill. So contour toolpath, change our tool to the, let's say, 202 1/4 inch ball end mill. And then we're going to let this go to not all the way through the stock, but we're going to stop it 1/2 inch down, so 0.5 inches. We're going to call this the pen recess. And then let's see what that looks like. Let's hide the toolpath. So you'll notice that the simulation that Carbide Create does, it's quite crude. The diameter of the ball end mill isn't calculated, but if it were, you would see two sort of scalloped tracks going around this pocket. So in order to have sort of a flat bottom pocket, but with a radius along the edges, you want to create a pocketing toolpath with a really small step over. So I will just basically duplicate the toolpath that I made, make another contour, pocket it. I'll go into edit my my cutting parameters and change my step over to I think about 10% is a good rule of thumb for like a middle of the road finishing toolpath. So 0.0125, whoops, decimal, 0.0125 inch step over. We don't need multiple depths per pass here, so I'm just going to say 1 inch depth per pass. It doesn't matter, it's just going to only touch the bottom once. And then this will be the floor finishing toolpath. And so you have one toolpath that sort of roughs everything out really quickly, and then a finishing toolpath that makes sure that the floor doesn't have those scallops in it, or it'll technically still have scallops, but it'll be super, super shallow. Alright, so that's it for this body. Let's do the finger recess. I'm going to basically do the same thing and apply a pocketing toolpath with a ball end mill. But if we do it this way, there's going to be a little bit of inefficiency as it sort of goes over the pen slot where it had been already cleared out. So you can just accept that it's going to take an extra minute or two of just cutting air as it traverses from one side of the pocket to the other. Or if you want to get fancy, you can split this circle into two hemispheres and sort of focus where the toolpaths work. So since I guess we have time, I'll just make a really narrow rectangle. Let's say 0.18 inches. Let's go 0.2. Nice round number. Apply that, and I'm going to select the circle, select that rectangle, and then do a subtraction. So that should split us up, give us two hemispheres. And now when we toolpath, I'm going to pocket out the top and the bottom hemisphere. I think I have to shift click to select those two separately. Still using the 202 ball end mill. Max depth, I'm going to stop this at 0.45 inches. Just to differentiate it from the pen cavity. Let's call this finger rough. And then we're just going to do it one more time. Pocket with a full depth of cut. Let's see. Oh, step over. Make that tiny. 0, 1, 2, 5. Okay. And then this will be the recess finish. So, show the simulation. What do we have? Okay, got the finger recess and the main slot for the pen. Cool. Hide simulation, save it just because. And then the rest of the features I will probably define with an 1/8 inch end mill. So let us select the pivot hole. That one we will pocket out to a slightly deeper depth than the magnet hole. The magnet hole we will do 0.07. This one let's do 0.045 seems relatively safe. Let's do that. Call this the pivot hole. Oh, I selected the wrong tool, so it thinks the diameter is too large to work. End mill 102. Hit OK, hit OK, and now we've got a toolpath in there. Let's apply a contour or a pocket to the magnet hole. This final depth will be 0.07. We'll call this the magnet hole. Hit OK. Let's see the simulation. Yeah, that looks about right. Shallow hole on one side, near full depth on the other side, hide simulation, and now we just need to cut out this body of the case. So, contour operation, make sure it's on the outside, make sure we're going all the way to the stock, bottom, and this will be final cutout. Hit OK. Alright, so show the simulation one last time. That looks pretty much like this. So that's pretty much everything we need. The only thing that's missing is that little pivot pin in the corner, which it's not exactly a dowel. It's sort of like if you take the cross-sectional profile, it's got like a T shape. So you could do that on a lathe, but you could actually do it good enough on a CNC. So I'm going to make a new design. I'll save this first. New design. Let's say we're using 1/2 inch stock. Okay. And it's really just making two circles. This will be the 0.125 inch diameter dowel that goes basically all the way through everything. And then the 0.0375 diameter or 1875 radius head on top of this to keep everything captive. And then just to sort of pocket everything out, I'm going to make a circle that's, let's go with 0.5 inches. Apply that. Oh, that's radius. Let's go 0.3. So the way this is going to work is I'm going to work on the skinny portion of that pivot pin first. So I'm going to pick these two, the innermost and the outermost contour, and pocket between them, 1/8 inch end mill. And that's going to give us something that looks like, if I have it cut deep enough, this is going to go almost all the way to the bottom. We're going to leave 0.1 inches proud, or 0.1 inches remaining. That's going to form the head of this pin. So we're going to go down 0.4 inches. Let's see that simulation. And then we need to cut around the head to cut this thing out. So that middle contour, that 0.375 inch diameter contour, we're going to cut on the outside of that to stock bottom, and we should be able to start at a depth of 0.4, assuming I got the clearances right. Let me double check. So that cutout toolpath, I want to be within the pocket. It's not, let's fix that. So basically what's going to happen is the first toolpath is going to clear out an area down to that flange. But my second toolpath assumes that there's enough clearance to plunge all the way down to the level of that flange and then start doing the contour around the last 0.1 inches. Not true. This needs to be just a little fatter, so we'll make that 0.35 inches. Apply, unselect, our toolpaths automatically update. So our first pocketing toolpath extends around the inner contour that will cut out this pin. So these three components, the pin, the case body, and the lid, are really all you need. Let's cut to some machining footage just to keep you guys awake, to show you what this process looks like. Let's get HD footage going on. And so the first thing I do is I'm starting with a roughly 1/2 inch thick block of walnut. The problem with this, because I'm storing it in my garage and I haven't touched it for months, is that it's not perfectly level. So I'm using some gator tooth clamps, a 1 inch surfacing bit, and I'm just manually jogging it back and forth to clean things up. You can see I'm being really careful about not crashing into the clamps. Once I have one good flat side, I'm going to flip it over. I'm just holding it down with some double-sided tape, and I'm just slapping that down on the wasteboard. I'm setting my 0. As you can see, I'll pause this. For the case body, I use the lower left-hand corner. I'm going to reopen that file for you guys. We'll discard that pin. So I've got my origin, lower left corner. There's a little bit of an offset here, which I can just get rid of if I just select everything and move it as a group. So if you want to just remove any extra margin relative to where you're zeroing towards, select everything, grab one of the corners, and just snap it to the corner. And then all the toolpaths will auto-update from there. So that's what I've done here. But I'm still centering just inside the corner, just in case my zeroing's off a little bit. And because my stock was so thick, I had to apply an extra pocketing toolpath to bring my thickness down to the requisite thickness of the lid. So this is just a long pocketing operation until I bring it down to about 0.2 inches. Do the contour, do the pinhole for the pivot. That one that you see right now is counterbored. And then to flip it over, to do the magnet, I'm using, I cut into my wasteboard accidentally, but it turned out to work really well because I could use it to align my lid to the position of the original lid. So that's how I found the X and the Y origin again. So I'm just using like a 1, 2, 3 block or a flat reference and using it to line up against the edges of my cutout. And then once I have that position known, I'll just sort of clamp down my piece and then machine the little magnet hole. And this is a really quick operation, shallow 0.07 inch pocket, done. And so that hole is going to be what we drop our magnet in. Let's see, any reason I didn't use a down cut? For this particular project, my stock thickness would be above about 5/8 of an inch. You'll see, I'll just let this play for a couple more seconds. I'm using a 3/4 inch maple, and the Amana 1/8 inch downcut that I have, you're getting really close to the shoulder at that point, so I don't have enough clearance to use that tool in this case. If everything you're making is thinner, you totally could use that. Let's see. Do I recommend surfacing any piece of wood that I'm using with? It depends. If you take your piece of wood, you put it on a flat surface, and you tap the corners, and you see it wiggling a little bit, that means you gotta flatten it. If, when you place it down on that surface, it's rock solid no matter which corner you tap on, you're probably good to go, but keep in mind you should try flipping it over first, because depending on how it's concave up or concave down, it might still be stable. But if you have any sort of wobbling, then yes, you should probably try to surface your wood or run it through a drum sander or a planer or just anything to get one good reference surface. And that's primarily if you're using double-sided tape. If you're using like top clamps, you're gonna basically flatten out that piece of wood. Just keep in mind that when you loosen those clamps, really loud car outside, when you loosen the clamps, the wood is going to unbow. So if you're trying to machine like a flat tray, that tray is going to pop back out and it's going to warp back to its original shape. So depends on what you're machining, if it's critical that it remains flat after you cut it out. And also keep in mind that wood is known for moving. If you take a large block of stock and you hollow it out, that wood, the moisture that's in the deeper parts of the wood are going to be released, and it's going to warp in a whole new way. So anyone who's like trying to chase like 0.05 millimeter accuracy in a wooden piece is really just deluding themselves. The wood is going to do what it's going to do. It's really hard to control. I'm trying to stay focused. Relax. So I machined out the pin in the same setup as the case body in the original file that I created. So you can see it's just working its way around. And the accuracy of that pin was actually pretty good. I modeled it as 0.25 inches, and it fit the holes like pretty snugly. So I'm pretty happy with how everything turned out. This is machining with the 202 ball end mill. So it's just doing the roughing pass right now, and then that is the finishing pass. It's just doing a lot of small step over pocketing. The finger recesses are being machined out now. I had one instance here, let me try and get the right frame, where I had a bit of chip out in the corner. If you were using, let's say, Carbide Create Pro, and you could rough this out with a down cutting end mill, that would kind of help here. Or in a more advanced software, you might switch this particular area to use climb instead of conventional machining. But that's just one thing to look out for. Certain species of wood are going to hold up better to this. Red oak, really fibrous, really coarse fibers. It's going to be even worse than this. So pick your species of wood carefully. And then we're going to pocket out the bottom on one side and then the other side. And that's going to be the finishing toolpath for the finger recesses. That's the pin here, if the camera will ever focus. So you can see I left a little bit of an onion skin here, and that was deliberate. Because I was using double-sided tape, because there was not a lot of surface area for that pin to hold, that onion skin just makes sure that this pin doesn't go flying or get dinged by the end mill once it gets fully cut out. So by keeping it captive, you can make sure that you don't damage the part, just to make sure that the fit and finish is all nice and dandy. You can just cut that out with like a scalpel or an X-Acto blade, and that is the fit of the pin in the rest of the pieces. I used a tung oil finish on everything and a bit of I think just regular wood glue on that hole. You want to spread the glue, just pro tip, on the inside of this hole, not on the pin, so that as you insert that pivot pin, there's no glue squeeze out on the top surface. If you were to reverse it, if you were to apply glue to the pivot pin and then try and insert it, that outer rim will just shave the glue and it'll squeeze out and it'll fuse your lid with your case. So So that's the finished one. There's a magnet held with CA glue in the bottom right corner. And yeah, so this is a really simple but kind of nice pen case you can make in Carbide Create. I used a router table with just a really small chamfering bit to just bevel the corners a little bit. You could use a hand plane, do whatever you want, but that just gives it a little nicer hand feel. The magnet alignment is pretty good. They snap together and they hold with the lid and the case body aligned. So yeah, simple project, but something you could do. That pivot pin is captured, and you can see that the clearances between the lid and that little head are really good. It's almost seamless. So that's without any like concern about like, do I creep up on that fit? That's just, I programmed a cut to be 0.25 inches in diameter, and I modeled it as such, and it just happened to work out to be perfectly seamless. So would masking tape help like in traditional woodworking? It would help on the top surface. The problem with that tear out that you saw is that the router bit is spinning, if you look at it from top down, in a clockwise fashion. So as you approach that left edge, it's basically trying to push the fibers out into that open recess. If you were to machine everything down at the same time and use a down cutting end mill, that would help compress the fibers and reduce the risk of that happening. How long did this take to finish? Let me pull up the actual file that I used. So recent files, pen case 3D. Let's discard this example file. Oh, I lied. That's not the actual file. That is the Carbide Create Pro example, pen case 2D. So this is the setup that you saw with the pin integrated with the same setup as the pen case body. Let's see. Keep in mind that I also had to face off a lot of extra stock here. So I had a pocketing toolpath that reduced the height of everything. I took off a 1/16 of an inch. Looks like about, I want to say, between 20 to 30 minutes. And I did speed certain parts up because once I got to the machine, I realized, hey, that 1/4 inch end mill is going through this maple super easily, so I just sped it up. But for this, about 20 minutes. For the lid that I did, because I was machining it from a much taller piece of stock, that took a little longer, especially because I was pocketing it out with a 1/8 inch end mill. Pen case lid 2D. Let's take a look at that setup. Oh, I need to re-enable everything. So I was cutting this out of much thicker stock than the lid itself actually was. So I had to spend a good bit of time just facing everything down. So that facing alone is roughly 11 minutes, and then just cutting out everything else was under 10. So if you have perfectly sized stock, this would be really easy. But because most people don't buy lumber in like 0.2 inch thicknesses, you're going to have to mill it down just to like get these dimensions to the right starting point. So you could conceivably knock this out pretty quickly in a like half an afternoon. You could batch out a couple of these. These files will be on Cut Rocket after this finishes. Milling the recesses before the pen slot would reduce the risk of tear out, definitely. Order of operations. So what David is saying is if we switched around the order of toolpaths, which is totally valid, I would want to move the cutout for the pen and finishing after the finger recesses. So you could right click and move this up, or one of the new features that I like that Rob snuck in here is if you click and hold, that toolpath will highlight and you can just drag it up. So machine out the finger recesses before the rest of the pen cutout. Let's see, is there a noticeable difference using the precision collet versus the standard collet for the Makita or Carbide compact router? The precision collet is basically on par with the stock Makita and a little better than the Carbide Compact Router stock collet. Let's see, how long did this take to finish? Wait, I already answered that. In terms of the tung oil that I used, though, I didn't use pure tung oil, so for the woodworkers out there, I sort of just knocked it out in 36 hours. One coat, 24 hours later, apply another coat, wait 12 hours and just glue it all together. Let me do a quick example of machining this out in Carbide Create Pro. So Carbide Create Pro, being that it lets you model a 3D shape from different components. So if I have the same contours as before, I can add them up, building up a... I'll show you the evolution of this model. First I took the main contour and I just extruded out the body, the volume that I'm going to machine everything out from. Next I added the pivot hole. So this is just selecting this contour and then applying a flat component that just subtracts from the top layer. That puts in one hole. Add in the pen recess that puts in the main slot. And then for this pen recess, I did a rounded edge. So if you select that contour, if you use a shape parameter that is round, actually, here, let me delete that. Let me disable this so I can show you from the start what that looks like. Use a rounded profile. Height limit, let's limit that depth to about 0.6 inches and make this a subtractive feature. Let's see what that looks like. We'll apply. We'll that is incorrect. I want the subtracting. I want I'm gonna make the angle -45. Let's see what that looks like. So give me a second, I'll figure this out. Subtract base height. All right. Let's see, give me a second to think about this. We want a, well, so if we were to just do a flat subtraction of 0.5 inches, that should just punch a hole in our stock, which it does. If we make it round and we apply that, show 3D, we get a little depression. And then if we, let's say, make that 90 degrees, that should give us a steeper edge transition. And then we want this to go a little bit deeper. So I think I can apply a base height to this for subtraction. And that'll give us a much deeper cavity. Okay, I still got it. So that would be how you would apply a cutout like that. I will put back in the original. The finger clearance cutout is just select the circle and do another subtraction. But there's a little bit of a difference here. Because if you do a pure subtraction across everything, you're going to have a reduction in height from the top face of the pen case, but you're also going to have a reduction in height in the pen recess slot. So the way around that is to use the min constraint. So if you were to do a straight subtraction, that would create something that looked like this. Not really what you want. By using the minimum function, it's basically creating a dish and intersecting that with a slot. And if you draw a line straight down from the top surface, whichever one it hits second is the height that it keeps. So it's just superimposing two features and figuring out which area is lower. We'll keep that one. In the middle, where the pen recess is deeper than that circular crater, it's going to keep the pen feature. Does Carbide Create have a list of post processors for different machines? Yeah, technically, kind of, sort of. We have, so when you first load up Carbide Create, it's going to ask you what post processor do you want to use. We have a couple different ones. We've got basic Gerbil, basic G-code, and the two for the our CNCs. In the future, there are provisions to potentially support other machines. It'll be easier for machines that use a more similar subset of G-code to what we use right now, but it is something that we are open to and may be able to help support. I don't think there's any documentation out right now about how to write your own post processor, though. I think... Nope, not the help. If you go into About Data Directory, under, like, you can apply your own fonts. I think you'll also be able to apply your own post processors, but we just don't have any documentation about that just yet, so hang tight. And let's see, the last few features to do this in Create Pro would be to add the little pocket for the magnet, and I think that's it. So you could create something like this. You can see that this is a continuously sloped surface. It's not like the one we made here, which basically just goes to a flat pocket here. So you can achieve different contours and 3D slopes using Pro. To create a toolpath for this, I would just select the bounding box of this body, apply a roughing toolpath to it, and then apply a finishing toolpath to it. And that's gonna, I'll disable one, show you what that looks like. So you can see the stepped texture. We're using a flat end mill here, I believe still an 1/8 inch. And then we're gonna come in with a finishing toolpath. You can use a ball end mill. You could even probably get away with a flat end mill, and then that's just going to smooth out everything else afterwards. And then of course you just select a 2D contour and do a cutout of everything. So, will this pen case be customized for a special coworker? I don't know. Christmas is still really far away. Depends on whether or not that coworker makes me a really cool t-shirt with a Carbide 3D logo on it and just even more swag. Is a flat end mill similar to a square end mill? Why, yes, Richard. Flat end mill is what I refer to interchangeably with a square end mill. I know some people take offense to that, but let's see. Do we have any questions on this project itself? Any permutations? Any general questions at all? Happy to entertain anything else regarding this project, or just any other questions you guys have, because we're at 50 minutes in right now. Do I have any other close-up pictures? So I'll just play this in the background to keep people entertained. Round end mills, ball end mills, they're pretty great. I will say that you can sort of tailor your finishing speeds and feeds because you're, so in, let's say, let me go back to the 2D example. When you're finishing up the floors of these pockets, you can actually increase your feed rate a ton because the you're not pushing through as much material. Once you've roughed out that middle slot, your finishing toolpath can be a lot faster. So I was actually running at like 150% feed rates. So instead of using the same feed rate for finishing as you would for roughing, you can crank this up a lot just to save a little bit of time. let's see. Okay, questions, finally. Why would I want to use this over the free version of Fusion 360? It really depends on what you're comfortable with. Like, I know plenty of people who don't really want to go through the learning curve of using Fusion. You can create this in Fusion, and in fact I did, which I can show you, just to do a render, so I could make a thumbnail for this live stream. The cutting out topographic features and stuff, the workflow in Create is a lot quicker just because it's a more lightweight program. It depends on the kinds of things you want to do. If you're making really complex things with like really specific dimensions, or you need special toolpaths, it's just one of those things that Fusion is better geared towards. But for a project like this, where your features are predominantly just 2D or 2.5D, that is perfectly. Let's see. Is Carbide going to selling those t-shirts? Crystal's got that. Set 0 with the touch probe at the tool change. Right now, I am using the bit setter, so between tool changes, I don't need to worry about that, but you could totally use a touch probe to set your 0, just make sure that your reference point hasn't changed. If you're like me, if you're starting out with extra thick material, that top surface is going to move as you machine it away. So if I had a block of stock where I was trying to set my Z0 height at the same point and I was touching off on the top of the stock, I would have to use an area of unmachined material if there was any left. If there wasn't, and I just blew through all my material and I pulled it off the machine or something, I'd have to reference a fixed area like the wasteboard. I used my shape logo with the HTZ. Was that for a reason? That just happens to be the only operational shape logo I have on hand. But for machining wood or plastics, you really wouldn't have to worry about it. It's kind of overkill. How would I rescue the project if you got glue squeeze out? If I did consider any alternatives for the pivot. So the thing about this project is, if I did get a bit of glue squeeze out, the areas that would be affected aren't really visible. So I could probably get away with just sort of forcing that that area open, as long as I didn't crack the lid. Because like, if there's a little bit of a grittiness of tear out on the underside of this, even when you flip it over, you're not going to see anything beyond about a 1/2 inch diameter. So you can hide your crimes pretty well. Let's see. All right, well, if that is everything we have today, so if there are no more questions, I will bid you all good day. I will put up the files for this project up on CutRocket. I will link to them in the description of this video, which you can always find in the Carbide Office Hours playlist on our channel page on YouTube. And let's see, do I have favorite woods I like to work with for projects like this? Let's see. Probably, I do favor a nice dry hardwood that's relative, like medium density. So something like walnut is just really pleasant to machine. Just make sure you're using dust collection or wearing personal protection when machining that, because walnut is one of those woods that can irritate the respiratory tract if you're not protecting yourself. Good luck, have fun machining, guys, and stay safe. Thanks for joining in.